How's it going, everyone? Evan here with a brand new series where I'm going to be giving you a more in-depth look at what goes into creating retro MMO. In today's episode, I'll be giving an overview of how the custom engine that I built for the game works behind the scenes. So to get started here, first I'll tell you a bit about the tech stack we're working with. I am programming retro MMO front to back with the TypeScript programming language, and I'll show my package.json here real quick if anybody's interested in seeing exactly what dependencies we're working with. It's actually a pretty minimal setup. A lot of these are just simple wrapper libraries. I'm not depending on any sort of pre-existing frameworks or engines to do any heavy lifting. And as far as our database goes, I am using MySQL with the Sequelize ORM. Moving forward here, there are really three main pieces to this application, which are the compiler, the server, and the client. I'm going to start off by telling you a little bit about the compiler. So the main idea here is that we have this config folder with a bunch of different JSON files here. This is where I do all the data entry for the game. All the game data lives here, things like, chests, things like character class data, tile maps, things like monster data, but also all of the UI components live here too, like panels, for example. I register all of those in this JSON file. Clickable images on the UI are all registered in this JSON file. And there's even some things in here that are just like very simple configuration variables, not like the types of things you'd see as environment variables, but just small things that you'd want to be able to tweak without having to dig into the code. Like, for example, the duration of actions in battle, just a number. And what our compiler does is reads off of these JSON files. You can see in here there's a different script for pretty much each one of these JSON files, and I write code that reads off these files and accordingly spits out whatever the client and the server need based on that data. Next, I will tell you about our server, which is a Node.js server, and it has many roles. This is by far the most complex part of the application. I should tell you that we are using two different forms of communication. We have HTTP requests as well as WebSocket communication. This route.ts here is where I declare all of the HTTP routes. This is mainly for hosting game assets, things like images and audio files, but there's also a couple different REST API routes for stuff like resetting your password, accessing the leaderboards. For WebSocket communication, it's mainly handling game logic. We're dealing with a very server authoritative architecture here. And what I mean by that is all of the game logic is run through the server to some degree. It's not processed on the client. The client sends a request to the server processes, and then it tells the client what happened. And a lot of that logic is in these listeners, but some of that logic is also in our update loop, which is a very simple game loop. It's just a set interval. And what it is this huge tree of if statements and different functions that loops through all the players and says, hey, based on the player state, update this, based on the player state, update this, loops through different game object states, and also does a similar sort of thing like looping through all the battles and saying, hey, if the battle's in this state, update it this way. If it's in this way, if it's in this state, update it this way. That is the general idea of the flow of logic on the server. Finally, let's talk about the client. So as I mentioned before, the server is what handles all the game logic, and what that leaves for the client to do is really just handle inputs and render things and play sounds. What we're looking at here is the HTML file that gets served when you load up the game client, and it's pretty small. The reason for that is because the entire game is run on a canvas rendering context 2D. What most of this HTML is for is the authorization menu for logging in and signing up, and also the chat box for sending messages to other players. And this is all, of course, styled with CSS. I'll show you my listen.ts file, which is where we listen for DOM events and accordingly send things to the server. That's what's happening for the most part, is that like a click happens on the canvas or a key down happens on the canvas, and we just tell the server, hey, we're trying to do this. And as I mentioned earlier, the server would then process it. We also have a bunch of WebSocket listeners in here. And these are mainly for the server telling the client, hey, update your state to say this, update your state to say that, and the client would then use that state to do its rendering and whatever other things. I'll show you two more pieces here, which are our loops. We have two loops on the client. We have a draw loop and an update loop. And these function very similarly to the update loop on the server. The difference between these two is that the draw loop uses request animation frame, whereas the update loop uses set interval. And these are just those really big trees of switch and if statements that are conditionally, in the draw loop's case, rendering things, and in the update loop's case, updating the game state. And since all the logic for the actual functionality of the game is server-side, all we're really doing in the update loop is updating animation states. So I'll leave it at that for this week. The goal of this video really wasn't to go too in-depth into any one specific part of the engine, but to give you that basic overview so that when I do come out with some more specific videos about the game's code, you already have a general idea of how things are working. I really hope you guys enjoyed getting a more behind-the-scenes look into Retro MMO. If you enjoyed this video, please let me know by leaving a like, and if you'd like to see more content like this, consider subscribing. You have no idea how much your support is appreciated. If you're interested in watching me work on Retro MMO live, head over to my Twitch page where I stream daily. There's a pretty good chance I am even live right now. Link is in the description. Oh, and before I go, I want to give a big shout out to the sponsor of this video, Covalence. Covalence is a full-stack web development bootcamp and is actually the school I attended. If you're interested in learning web development, I highly recommend that you check them out with the link in the description. Covalence's goal is to bring you from zero programming experience to a career-ready software developer, and that is exactly what they did for me. So once again, thank you so much for watching, and I'll see you in the next one.